Welcome and thank you for joining us today on our Bühler Technologies online seminar about hydrogen components for gas analysis, properly monitor volatiles. Our presentation will focus on hydrogen and oxygen compatible components for gas analysis and the safe monitoring of volatile gases. But before diving into the webinar, perhaps a few words about our settings. You can ask questions anonymously. There's a speech bubble with a question mark on the top right corner. We will answer some of those questions directly or afterwards, depending on the scope. You can download our documents. The link will come later in the chat. And please, when you leave the webinar, you will be directed to a feedback section. And please leave us feedback because we always want to improve ourselves as well. My name is Carsten Sambraus and I'm Head of Innovation at Bühler Technologies. This is our agenda for today. Let's start with a short introduction of Bühler. Together with our partners, Bühler Technology develops innovative solutions that combines both new and proven technologies. With our products and services, we contribute to the responsible use of limited resources and make an important contribution to keeping our environment clean. Bühler Technology was founded in 1969 by Mr. Bühler and Mr. van Amelen as an industrial agency for hydraulics. 1 year later, in 1970, we also started with gas analysis. In 1976, the name was changed to Bühler Mess- und Regeltechnik, and in 1995, we restructured and set up our own design and development department. In 2006, the company was renamed Bühler Technologies GmbH. In 2007, we started our international expansion course with sales offices in China, Asia, CIS states, as well as subsidiaries in the United States of America and France. With Bühler Innovation, we founded an independent innovation company that focuses on the development of new ideas outside of our day-to-day business. Our industry focus is on emission measurement in power plants and process gas analysis in the chemical, petrochemical and biochemical industries. We recognized early that on measuring emissions from the combustion of fossil fuels is a limited business model. For this reason, we aligned and further developed our components to the new value chains of alternative energy systems at an early stage, thereby expanding our business focus to include renewable energies and alternative fuels. Today, these future-oriented topics are the central components of our work. Bühler offers both components and complete systems for gas conditioning. The focus of the components is on effective gas conditioning, which is ensured by specially developed gas sample probes, powerful and durable gas pumps, and gas drying units with Peltier and compressor coolers. In addition, analyzers from various manufacturers are used, which are optimally adapted to the requirements of the respective measuring task. In the field of systems construction, we offer modular 19-inch systems for one or more gas paths, as well as analyzer systems designed according to customer specifications. We also supply transportable or stationary conditioning systems with integrated analyzers. Hydrogen demand. The course for the transformation of our energy systems has already been set, and the political goals and timelines are clearly defined. Demand for hydrogen will continue to rise between 1990 and 2050, and we see this as a great opportunity for our company to take a relevant position in the new markets. For Bühler Technology, the increasing demand for hydrogen between 1990 and 2050 means entering the value chain of the hydrogen economy. We aligned our component portfolio to this market at an early stage. The focus is on open technology production of hydrogen using both green electrolysis processes and conventional production methods, which will continue to serve as a bridging technology in conjunction with carbon capture, utilization and storage for a long time to come. What is critical about hydrogen? Its explosiveness. Explosions occur when ignitable gas mixtures come into contact with an ignition source. Therefore, the safe avoidance of leaks to prevent gas accumulations is a top priority, along with the avoidance of all ignition sources. The explosion range is particularly relevant for hydrogen-oxygen mixtures, as these cover almost the entire range of the explosion triangle. In a research report, the Federal Institute for Materials Research and Testing examined pressure, temperature, and mixture ratios in detail. It came to the conclusion that the lower explosion limit is reached at about 4% hydrogen in a hydrogen-oxygen mixture, and the upper explosion limit is around 94% of hydrogen. Dangerous oxygen-hydrogen mixtures must therefore be avoided at all costs. Under no circumstances should there be any sources of ignition, so that no ignition energy is generated in the event of unintentional mixing. The ignition energy of hydrogen is extremely low and is only at 0.016 millijoules. For comparison, this amount of energy corresponds to the energy of a grain of rice falling from a height of 10 centimeters, 4 inches, in other words, very, very little. For this reason, all Bühler hydrogen-oxygen ready components place particular emphasis on tightness and cleanliness. Hydrogen is a very small molecule. Hydrogen accumulates on surfaces, which is called adsorption, penetrates into the materials, which is diffusion, and can be released again on the opposite side, which is called desorption. Metals in particular are susceptible to diffusion and embrittlement. Temperature, pressure, and choice of material influence permeability. Coatings and multi-layer systems help to minimize these losses. This is why Bühler Technologies subjects all hydrogen-ready components to a 100% leak test. And with helium. Why helium? Elementary hydrogen consists out of 1 proton and 1 electron. Helium consists out of 2. However, hydrogen does not occur in elementary form, but mainly in bound form as an H2 molecule. This molecule is lighter than helium, but larger. This is because the 2 protons in the helium nucleus exert much stronger attraction to the electrons than the 1 proton in the hydrogen nucleus. Let's have a look into the chat, whether there are questions. And yes, I see there are already some, and I read the question out for us. Why is it important to calibrate measuring devices for hydrogen-oxygen analysis with a DAKKS certified standard? The leak testers used by Bühler Technologies are supplied with a DAKKS accredited calibration certificate in accordance to the governing regulation, which is DIN EN ISO 17025. DAKKS is the German accreditation body. Norms and standards actually specify what must be measured and how exactly, and test laboratories are carrying out these measurements. Through accreditation, the DAKKS officially confirms that these bodies work according to the international standards and are professionally competent and independent. This ensures confidence in test reports, certificates and inspections, both nationally and internationally. I see that there is another question. What are additional protective measures which are required to detect and prevent leaks in hydrogen systems at an early stage? And the sufficient answer is, of course, don't let it leak in the first place. That means that a great care must be taken when selecting materials and sealants. Nevertheless, the issue of 100% technical tightness is a very specific topic. System components are considered to be technical tight in the long term if they are designed in such a way and remain technically tight due to construction principles, or their technical tightness is constantly ensured through maintenance and monitoring. Bühler Technology can control its components throughout the entire design and manufacturing process until delivery to the customer. From then on, the tightness is subject to maintenance and monitoring, which is not under our direct control. Let's get back to our presentation again. What is the danger of oxygen? Look to the handling of oxygen shows how important correct handling is. Anyone who has completed an apprenticeship in the metalworking trade will certainly remember how to handle oxygen cylinders during gas welding. Never ever use oil or grease to lubricate those oxygen equipment. This principle is laid down by IGA, safety and technology-oriented organization representing European and non-European manufacturers and distributors of industrial, medical and food gases. IGA is committed to the highest safety and environmental standards and work closely with standardization organizations, authorities and industry associations. In addition to the IGA recommendation on the cleanliness of oxygen supply devices, Bühler also relies on methods and procedures for cleanliness analysis as used in the automotive industry when testing technical cleanliness of its hydrogen-oxygen components. This ensures that all contaminants are removed, including both organic and inorganic substances, such as oils, greases, markings from crayons and other markers, lubricants for threads, paint, cleaning agents and their residues, welding spatter and slag, rust and scale, metal particles, sand, dirt, lint, fibers, rags, paper, wood, coal, dust and other foreign matters. If this cleanliness is not guaranteed, these impurities can lead to ignition in an oxygen atmosphere. Are there some questions? Another question, some more questions in the chat? Yes, they are. What are the special purity standards IGA Doc 33/18 essential for oxygen systems and which impurities must be removed? Well, I have just remained I've just named the type of contaminants that need to be removed. This was the long list ranging from scale and slag to pins and markers. Now it depends not only on the kind of the contaminations, but also on the type. Is it more elongated particles such as fibers or fluff, or rather compact particles such as sand or metal shavings? And that also has to be recorded somewhere. What sizes are relevant? Because we can't remove everything down into the atomic range. There is a critical bandwidth, and the limit values are between 500 and 1,000 microns. And in addition to the threshold for those sizes, the number of the particles is also important. All of this is defined in the purity standards, and it is very important to have them, so that all those impurities can be removed in a targeted manner. Let's now look at the necessary care in the process chain. In electrolysis, in addition to analyzing the gases, it is also crucial to consider the potential hazards when operating our components. This is done through carefully risk analysis and assessment of the materials used, and by carrying out ignition hazard assessments during operation. The process begins with the worst case analysis of the operating condition, followed by testing suitability of materials. Possible ignition mechanisms are then set up and evaluated in scenarios, and finally the reaction effect is determined and evaluated to ensure that all potential hazards are identified at an early stage and addressed accordingly. In addition to looking at the components themselves, how they are handled is also of great importance. A component that has been thoroughly cleaned loses its value if it is contaminated again during assembly. A special working environment with specific cleaning rules has therefore been created for hydrogen-oxygen ready components. Bühler Technologies is a component manufacturer with all the necessary core competencies. For the special cleaning technology of hydrogen-oxygen components, we work together with highly specialized cleaning professionals. All our components are professionally and properly cleaned there. These components are then returned to the company via the incoming goods department and are subject to mandatory labeling and a ban on unpacking. Packaging is checked for damage and components are rejected if necessary. This special treatment applies from the outset to all hydrogen-oxygen ready components in order to guarantee their quality and safety. Hydrogen-oxygen ready components differ from conventional components mainly in terms of handling and the use of special materials, but are almost indistinguishable to the naked eye. For Bühler, however, these components represent a completely different product. For this reason, they are managed separately in the ERP system from the outset and separated from conventional production. In the production process, they are subject to special process instructions and special tests, which are confirmed by Bühler Technologies in hydrogen-oxygen declarations. Here's an example from electrolysis product manufacture. In electrolysis product manufacturing, a special in-feed process is used to bring the components into the clean room for further assembly. Each clean component is individually double-packed and labeled. Before entering the clean room, the outer packaging that has been touched during transportation is first removed to ensure that only the inner contamination-free packaging enters the clean room. In the clean room, the inner bag is opened and the component is further processed with the necessary protective measures such as gloves and masks. Dedicated tools are used exclusively in the clean room and must not leave it. The clean room is controlled in such a way that the air atmosphere is constantly monitored and access is strictly limited to prevent possible contamination. The aim of these measures is to control the level of contamination in accordance with the defined specifications. The upper limit for particles between 500 micron and 1000 micron must not exceed 22 particles. In addition, no particle may be longer than 1000 micron. Isolated fluff of fibers must not exceed the length of 2000 microns. These limit values ensure precise and controlled cleanliness, which is crucial for the flawless use of our components. The process capability of the cleanling is checked annually and documented in the Acceptance Test Certificate 3.1 in accordance with EN 10204. This example, it is clear that no particles between 500 microns and 1000 microns are present. The first particle only appears in second class below the lower limit and is only 1/3 the size. Critical metallic particles are only detectable in the fourth class below the lower limit and are only 1/6 of the size. This careful approach is necessary to ensure safe operations in hydrogen-oxygen applications. Our products. Over the last 2 years, Bühler Technologies has developed a range of products specifically for high-purity hydrogen and oxygen applications. This range includes sample gas coolers, sample gas pumps, and automatic condensate drains. All pumps are therefore offered exclusively as ATEX or MX certified. The hydrogen-oxygen-ready sample gas coolers from Bühler Technologies are also approved for ATEX and IECX Zone 2. Special variants also fulfill the FMC US approval for Class 1, Division 2. Heat exchangers that are in direct contact with hydrogen as wetted components are annealed at around 250 degrees C for 4 hours. This process allows hydrogen molecules to diffuse into the metal where they react with undissolved gases such as oxygen, nitrogen or carbon. This removes the gases from the metal, preventing embrittlement and other undesirable properties. For applications with oxygen, Bühler Technology confirms with this declaration that all surfaces of the listed products that come into contact with the medium have been cleaned and manufactured in accordance with the specifications of IGA Doc 33/18 and VDA Volume 19 to ensure freedom from particles, oil and grease. For applications with hydrogen, Bühler Technology confirms that these products have undergone special material refinement measures during production. These include professional component cleaning, hydrogen effusion, annealing, and a final leak test with helium to ensure the highest safety and quality standards. In this way, Bühler Technology ensures that operation of its components in hydrogen and oxygen applications. Your contacts are Wolfgang, Ralf, Oliver, Liu, Chao, Zhang, Frederick, Mara, Mikhail, Vincenzo are happy to take your call. Here you see a few faces. As you've seen, we are present nearly around the globe. Please proceed to our website, and there you will find your details about your contacts according to the region where you are. Let's have a look to the chat again. Are there more questions? Yes, there are. What are the new markets emerging for hydrogen technologies? The good news is that a market for hydrogen already exists. For example, hydrogen is used in the chemical industry or for the production of fertilizers. These markets are already there. The new markets that are now emerging are about reduction of the CO2 footprint and producing hydrogen from renewable sources. With the products we have presented today, Bühler wants to take a relevant position there. Next question. What are conventional sealing materials often unsuitable? Why are conventional sealing materials often unsuitable to hydrogen applications? And which special materials should be used instead? Thank you very much for this question, because it's a very important, as it is currently being discussed very controversially in the context of PFAS. PFAS stands for per and polyfluorinated acryl substances. This is a group of industrially produced chemicals with very special properties for which there are actually no alternatives in the hydrogen industry. Well, the industry has found its point of view on that, and Bühler is in agreement with that. But however, we are also working with manufacturers of sealing materials on alternative materials, but Teflon is really a very, very good material for that application. Well, now we have already reached the end. We are still available for a few minutes in the chat. Please take advantage of this opportunity. We'll be happy to answer anything we can't do now afterwards. And I hope I was able to make the topic interesting for you. And when you leave the webinar, please leave us your feedback. Thank you for your interest, and I look forward to our next virtual meeting.